This day we have the question. It's from chemical bonding regarding hybridization, structure, shape, etc. Identify the correct statements. First one, NO2, NO2 minus and NO2 plus have same hybridization for nitrogen. Second, I3 plus and I3 minus are both linear. Third, ClO2 plus and the ClO2 minus are all angular. And the last one, CO and CO2 have same hybridization for carbon. We will check one by one. One, NO2. See, in NO2, we have the rough diagram as N double bond O like this. So, it requires two unpaired electrons and one lone pair. As we know, in nitrogen there is already there are three unpaired electrons and one lone pair which are required. Here, the hybridization to be involved must include the orbital that contain the lone pair as well as the sigma bonding. This is the lone pair, this is the sigma bonding orbital, and this is the pi bonding orbital, and one orbital will remain with an unpaired electron. Hybridization involved all the three sp2, all the three that contains electron pair, lone pair electron, sigma bonding electron, and lone electron which is not involved in bonding, save pi bonding orbital. Pi bonding orbitals are never hybridized. So we have sp2 hybridization with one lone pair, one sigma bond, another pi bond, and another one lone electron. The molecule has a bent or angular geometry with the hybridization being sp2. 1a. 1b. NO2 plus. See, whenever a plus charge comes in a species, in most cases that plus charge is on the central atom. And whenever a negative charge comes on such a species, in most cases that negative charge on the attached atom. So here we have the plus charge on the nitrogen atom. Then we have like this only. One electron has been taken away. Now we have the rough diagram, approximate diagram. N double bond O, same. See here we have the lone pair, we have the sigma bonding orbital, we have the pi bonding orbital. So this is the lone pair, sigma bonding, pi bonding, that's empty. We know pi bonding orbital should not involve hybridization. So it will have sp hybridization. And the molecule will be linear like this. So NO2 plus is a linear species involving sp hybridization. Now NO2 minus. NO2 minus. Here the negative charge should be on the attached oxygen atom. So we have the central nitrogen. And here two oxygen, one might be having this double bond, other is bonding with one electron like this. Rough diagram will be like this. So the lone pair will be remaining. So it must be involving sp2 hybridization because one lone pair will remain as a lone pair, sigma bond, pi bond. Two sigma bonds are there, one pi bond is there. So it must be involving sp2 hybridization. So it must be bent. It is not like this. It is a rough diagram. sp2 bent. This is linear. So our conclusion, all are having same hybridization. Now we come to the conclusion that's a wrong statement. It's a wrong statement. Now we have I3 plus and I2 minus. I3 plus. Whenever there is a plus charge, that should be on the central atom. So we can have this like this, I plus, I minus, I giving I3 plus. So the central atom, halogen family, one electron has been lost, so it is not paired. This is the I plus state. Now it has to form two bonds. So two lone electrons are there which can form sigma bond with the two neighboring hydrogen atom. So it must be involving sp3 hybridization. sp3. This will remain as a lone pair. This will remain as a lone pair. This will form sigma bond. This will form sigma bond. So the species will be with the two lone pair. sp3 tetrahedral. Tetrahedral is the electron pair geometry. Electron pair geometry is tetrahedral, whereas molecular geometry which excludes the lone pair is bent or angular. Bent or angular. Now we have I3 minus. I3 minus. Here it must be like this. I plus I minus. That must be giving I3 minus. We have halogen iodine with the electronic configuration like this. So by using this unpaired electron, this central iodine can form a bond with this iodine. Okay. So it wants to accommodate a lone pair of electron donated by a second iodine. So it has to make use of the vacant d orbital. This orbital it make use of. So sp3d. So in the final structure, this will be lone pair. This will be lone pair. This will be lone pair. This will be forming sigma bond, and this will be coordinate bond, coordinate bond. So the shape will be I, 3 lone pair, means electron pair geometry trigonal bipyramidal. Bipyramidal, shape linear, or molecular geometry linear. Electron pair geometry corresponding to sp3d hybridization will be trigonal biplanar. Coplanar and trigonal bipyramidal, not trigonal biplanar, trigonal bipyramidal, and the shape linear. So what is the statement? I3 plus and I3 minus are both linear is wrong, and the wrong statement. Now we have the third statement, ClO2, ClO2 plus, ClO2 minus. ClO2. We have chlorine atom. Here we approximate the diagram like this, double bond on both sides, or one double bond and a coordinate bond. It can be either way. Okay, we have halogen with the configuration. Like this. To form two double bond or one double bond and a coordinate bond, it will be easy if you explain like this, one double bond and a coordinate bond. A lone pair is required, which is already there. But this must be a sigma bond and pi bond. So there must be excitation producing more unpaired electron. So we expect an excited state. This is Cl. We have now Cl plus. I'm sorry, Cl star, which suggests an excited state. So that now it has 3 unpaired electrons. We want only 2. So we know that the lone pair as well as the sigma bonding orbital must undergo hybridization, but pi bonding orbital should not involve in hybridization. So this is lone pair, I hybridized, lone pair hybridized, sigma bonding hybridized, lone electron hybridized, but pi bonding electron not hybridized. This is pi bonding. So we have sp3 hybridization. sp3 hybridization with the Cl, double bond O, single bond O, a lone pair electron, a lone electron. So it is sp3, tetrahedral and bent. sp3, tetrahedral electron pair geometry and a bent shape. Okay, so it is angular or bent. Now ClO2 plus 3b, ClO2 plus. Whenever a positive charge is there, it is on the central atom. So we have the chlorine with the electronic configuration. One electron has been removed, so it will be similar to oxygen, and it has to form, say, 2 double bond or 1 coordinate bond and 2 a double bond. In that case, we can proceed with this lone pair, coordinate bond, sigma pi. So pi must be avoided. sp2 hybridization. So Cl, double bond O, involving sigma and pi, and a coordinate bond, and it is having a lone pair. So this is also bent. This is paramagnetic. This is dia. This is para. This is dia. Now we have 3C, ClO2 minus. Whenever minus charge comes, it's on the attached atom, which is more electronegative. Cl, O minus, O double bond, possibility. So it wants to form 3 bonds. Since it required 2 sigma bond and 1 pi bond, there must be excitation. Cl star. Okay. This is lone pair, lone pair, lone pair, lone pair, 2 sigma bond, 1 pi bond. Pi bond should not be hybridized. sp3. Lone pair, sigma, sigma, pi. Pi is not hybridized. So Cl, double bond O, single bond O with a minus charge, lone pair, lone pair. So tetrahedral, bent, diamagnetic. So this is bent, this is bent, this is bent. This statement is correct. Third statement is correct. Even though hybridizations are different, all are bent. And the last one, CO and CO2. CO and CO2. First we look into CO. Carbon. We know valence configuration. It wants a double bond. Normally, it wants a double bond. Sufficient electrons are already here. So, this will remain as lone pair. Sigma bond, pi bond. So, sp hybridization. So, of course, in the resonance structure it has triple bond, but in the basic structure we can write it like this. So, CO, sp linear. CO2. Rough diagram like this. Electronic configuration. It wants 2 sigma bond, 2 pi bond, but there is only 2 electrons, so we have to excite. We have to consider excitation. Okay, only 2 bonds are sigma, 2 are pi. So sp hybridization only, not sp2. So sp leads to linear geometry with the 2 sigma bond and 2 pi bond. So both CO and CO2 involve sp hybridization. In CO, there is no prior excitation, direct sp hybridization. In CO2, after excitation, again sp hybridization. Both leads to linear geometry. So the last statement, CO and CO2 have the same hybridization, so C is also correct. So that option has to be accepted, which say 3 and 4 are correct. See how much time we have taken to explain this question. So I recommend you to make these things by heart. These 3. Several times asked they in group. So make them by heart. That's a better thing to save time. Take it.